My name is Mohit Maheshwari and I'm a software developer at Tata 1MG. And today I'll be presenting a talk on async reducers and where we'll be discussing how we use this approach to reduce our app bundle size in the process. So before we get started, I hope everyone listening to this talk have a fair understanding of what Redux is and how the React Redux system works so that it is easy for everyone to follow along. So with this said, let's begin. So if you look at this diagram over here, what we have a store. Now this store have multiple reducers, namely the shell reducer, or you can also call it the app reducer if you want. We have the home reducer, the cart reducer, and there are other reducers as well. Now, traditionally, how we create pages in React and Redux application is that whenever we create a page, each page most oftenly brings along with its own reducers and its own actions now, and we typically import all the reducers at one place and we combine them using the combined reducers and we initialize a store with it, regardless of whether we actually need all the reducers at one go or not. So now this can be better understood with an example. Let's suppose that if you are on an e-commerce site, okay, you are on their homepage and you search for a particular product, and based on that search the you have some list that is available for that particular product. Now, if this was here and you close the tab, now this was your journey for the e-commerce site. Now, if I talk in terms of the reducers used, we can map this accordingly. Like you started from the home page, so you were using the home reducer for that particular thing. And since you were searching for a particular product, you might have used the search suggestion reducers as well because they must have suggested you certain products related to that particular keyword, and based on the search you must have the product listing page, so you have used the product listing reducer. But there was no requirement of the cart reducer because in the entire journey you never visited any cart page. So but still the cart reducer was part of the store, and hence it became part of the app bundle regardless of whether we actually used it or not. So now this might not be a major issue if we have a small or a medium scale application. But as our application grows and our number of pages keeps on growing, this actually becomes a problem because our app bundle size keeps on increasing. So just to give an overview, as you can see from this image, so this is the app bundle of our 1MG. So you can see the app bundle, and this image was something a few weeks back, where you can see the app bundle size is roughly around 138 KB in gzip format, or near about 750 KB. And you can see that the majority of our app bundle comprises of the reducers and the actions itself. So you can think of that whenever we actually create a new page, we are actually adding roughly around 15 KB of extra data to the app bundle, depending on whether you are going to use it at that particular moment of time or not. So the question now arises over here is that we divide our entire application into multiple chunks, right? We load the relevant JS and the CSS of a particular pages on demand. So why can't we do the same for reducers as well? After all, let's suppose that if you're on a home page, the home reducer makes sense. But if I'm on a product detail page, or if I directly landed on that page, I don't have any requirement for the home reducer because that particularly caters the need of the home page itself only. So this was our thought process, but this thought process came along with its very own challenges as well. So this is how we actually we planned to import add the reducers to the chunks as well. So if you look at the before examples, if you look over here, we have the home page. It has its own widgets, its own container files and all. But we wanted to add the reducers as well. So the reducers become part of the each and every page bundles. And whenever we navigate, suppose that we land on the home page, then the home reducer becomes part of the store itself, not before that. So we technically we are loading the reducers on demand rather than before in the initial load. So, but this thought process had its very own challenges. So these were the three most important challenges that we faced. Now the first was actually there was no defined method to actually lazy load the reducers. So if you look at the web for this particular problem statement, you would actually find, the resources are very scarce to this particular problem statement. And eventually, if you are able to find there are certain resources, they use the React Redux context APIs. Now, to give an overview what this API is, it's a very low level API that is used by the React Redux library itself to expose us the methods like the dispatch or the replace reducers and other methods that we typically use with the React Redux library. And the React Redux, docs itself mentions that not to use this, to avoid generally using this low level API so that it does not break our entire applications. The second problem that we faced was we have to make sure that our reducers, the our method particularly works both on the server side and on the client side as well. So now this was something important because if the reducers don't get attached properly on the server side, this would have impacted how we are creating our doc, and it would have actually, our performance would have taken a negative hit. So, and the third challenge that we faced over this one was actually an interesting one. This was something that we encountered while we were actually implementing the solution. So the problem was that whenever we add reducers to the server side, we were able to add the reducer dynamically, and we were able to get the state working as well. The thing is that we can get the state from the server side to the client side by stringifying the entire state, but we cannot get the reducer from the server side to the client side because reducers are basically functions, and we cannot just stringify it and just pass it from the server side to the client side. So we'll be looking on how we actually countered this problem, but first let me discuss how we approach this one. So the approach that we had, so basically this approach actually comprises of two particular things. So one is the reducer manager. Now, basically, it just exposes us the methods to, add the reducers on demand, or just exposes us the method on how you'll be adding, or for the default reducers you want to initialize your store with. The second method is a middleware that actually acts as a bridge between the reducer manager and the page itself. And the job of a middleware is to actually look whether the it needs to actually execute the reducer manager method or not. So we can understand this better if we look at this example. So I've prepared a sample code for this one in the sandbox. So basically, the app is a simple one. So basically, it has a home page and it has a cart page. So if you click on the cart page, we are going to the cart, and similarly, we are on the home. So this is a basic app. Now, what I meant by reducer manager was that if you look at the reducer manager, what we have, we actually import the default reducers over here for the initial state. Now, what I mean by default reducers, so basically these are reducers that that are actually be going to be used across the entire applications. So, like if we would have a footer in this one, we would have imported the footer reducer because we know that we are going to need the footer for each and every page. So it made sense to actually add this beforehand rather than making it part of each and every page bundle. So this is what the default reducer comprises of, and this reducer manager comprises of two methods particularly. So first is the get reducer map, sorry. So this the is simply how we actually combine the reducer. How we used to combine the reducer is just the same as that. The only thing is that it only create a store using the default reducers that we are actually importing over here, right? The second is the add method. This is the most important method. The job of this particular method is to actually take the reducer as an argument and add this particular reducer if it's not already part of these reducers keyword. And if it's and to after adding it, combine the reducer and just give us a single object, like a single store. That how we are using it for the other cases as well. Now, if we look at the reducer manager, we can actually expand it to other use cases as well. Like, let's suppose that if in future that if you want to, somehow want to dynamically even remove the reducers, we can actually have we already have a method for this one to actually remove the reducers dynamically. So what we can do is that it is going to take the reducer, it's going to delete the reducers, and we are going to, the update the store with it. So this is how it's actually working, or this is how the reducer manager looks like. Now, if we look at the store part, So this is how our actually store looks like in this particular scenario. Now the store, actually the middleware that we were talking about was the ad reducer. Now the ad reducer has two important job. First of all is to actually when the server is when the store is initialized first on the client side, it has to make sure that we first forcefully execute the reducer manager add method. Now this is because we are not able to get the reducers from the server to the client side itself. And the second job of this ad reducer middleware is to actually look whether we have already added the reducer in the store or not. So let's suppose that if I am on the cart, if I navigate to the cart page, right, and I come back to the home page, I was already on the home page and the reducer was already added. So it's not going to actually, actually execute this. It's not actually going to replace the reducer. It's just, just going to return this because the reducers we are already present and it's going to work fine without it. Now the thing with this now the other thing that we had is a simple function. Now this add required reducers are nothing but just a simple function whose job is to actually take the reducer and just call the middleware with it. And how we are actually using this one is that if you look at the home page over here, we are actually importing this middleware, and then we are actually dispatching it, and we are passing the reducer that we want to add to this particular page. Now this particular method is going to call the middleware and it's going to add the reducers on demand as well. So if I show you how this looks like now, if you look over here, the initially when we initialized the store, the only reducer that was part of the store was the shell reducer. But since we started from the home page, the home reducer became part of this of the reducer itself. Now, if you look at the card also have the similar code structure, nothing difference. Only the difference is that we are importing card register for this one. So if I navigate to card, let me first clear the console. Yeah, you will see that we are adding the card reducers as well over here. So this is how we were actually using this particular approach to dynamically add reducers, and by this particular approach, we were able to, more or less actually reduce our app bundle size by a significant amount. So if you look at the advantages that we had, so the first of all, the straight advantage that we had, our app bundle reduced, by significance. So if you look at if you have looked the image on the initially, we were touching around somewhere around 138 KB gzip, but our current app bundle is now of 42 KB gzip, which is a great reduction in terms of size. Now, another added advantage that we had was that our code coverage, which was used to be 40%, increased by 20%. So we were roughly around 61% of our code coverage. And the biggest advantage I think that we actually had with this particular approach is that we can ship any number of pages and we can add any number of reducers without actually ever worrying about how that is going to impact our app bundle size. So with this being said, and there's actually a fourth advantage. So that is something that is not particularly mentioned over here, is that our LCF also dropped by zero point 0.8 seconds as well. So this was another advantage that we see with this particular approach. So with this being said, this is what our final app bundle looks like. You can actually see that it's way neater than the app bundle that we used to have a few weeks back, and this and it's also a very small size, so we are roughly 41 42 KB near about. So these are the advantages that we had using this async reducers approach. So thank you very much. So if you have any doubt regarding this, or you have any questions, you can feel free to connect me on any of the platforms of your choice, and I'll be happy to discuss this in great detail. Or if you have any other topic, I'll be happy to discuss that as well. So thank you everyone.